Hello, I am Prajakta Hanamgaon from TYCSE AIDS. So, today I am going to explain Introduction to Convolutional Neural Network. So, first we understand Introduction to Neural Networks. A neural network is a type of computer system inspired by the way the human brain works. It made up of layers of nodes called neurons, which are connected to each other. Each neuron receives input, process it, and pass the result to the next layer. Neural networks are designed to recognize patterns in data and learn from examples, which make them very useful for tasks like image recognition, speech understanding, and more. In simple terms, a neural network takes some information, process it through multiple layers, and produce an output, like identifying if a picture contains a cat or not. The neural network learns by adjusting the connection between neurons based on the errors it makes improve its accuracy over time. Next, we understand why convolutional neural network. Convolutional neural network or CNN are special type of neural network designed specially for the working with image and visual data. Unlike regular neural networks, CNN can automatically detect important features like edges, shapes, and texture from image without needing manual help. The reason we use CNN is that they are very good at understanding images because they look at small parts of the image at a time called filters or kernels. These help the neural learn patterns like lines or curves and then combine them to recognize more complex shapes like eyes or faces. CNN are also efficient because they share their filters across the whole image, which reduce the number of calculation and help the neural learns faster and better. This makes CNN to go to choice for the image related tracks such as the object detection, face recognition, and even medical image analysis. In next slide, we see the basic structure of CNN. The convolutional neural network has a spatial structure made to process image effectively as follows. First one, convolutional neural network. This is the first important layer. It uses small filters that slides over the image to detect simple features like edge, color, and texture. Each filter creates a feature map showing where the feature appears in the image. Second one is the pooling layer. After convolution, the pooling layer reduces the size of the feature map. It does this by summarizing small regions, usually by taking the maximum or average value. This makes the data smaller and easier to process while still keeping important information. Pooling helps the network focus on the most important features and also reduce the chances of overfitting. Third is the fully connected layer. After several convolutional and pooling steps, the network flattens the features into a long list and pass them to fully connected layers, which work like a traditional neural network. These layers combine the features to make the final decisions, such as classifying what the image shows. Together, these layers help the CNN learn from image by first capturing simple patterns and gradually understanding complex shapes and objects. Next, we understand the convolutional operations. The convolutional operation is the key process inside a CNN that help it understand image. It works by sliding a small filter over the input image step by step. At each position, the filter multiplies its value by the corresponding pixels of the image and add them up to get a single number. This number becomes part of a new output called a feature map. Think of the filter like a small window that looks for the specific patterns like edge, line, or texture inside the image. By moving this window across the whole image, the CNN can detect where these patterns appears. This process helps the network focus on important parts of the image while ignoring unnecessary details. By using the many filters, CNN can find many different features which are combined later to uh, recognize objects or shapes in image. Next, we understand the ReLU Activation. ReLU stands for the Rectified Linear Unit, and it is a popular activation function used to CNN and other neural network. Its job is to help the neural learn complex patterns by adding non-linearity. ReLU work very simply. It take the input value, and if value is positive, it keep it as it is. But if the value is negative, it changes to be to zero. So mathematically, ReLU output the output itself if it's greater than zero. Otherwise, the output is zero. This helps the network because it allows it to ignore negative signals, and which often does not help the learning important features. ReLU also makes the network faster and helps prevent some problems that other activation functions face, like slowing down learning. Next, we understand the pooling layer. The pooling layer is used in CNN to reduce the size of the feature maps that comes from the convolutional layers. Its main job is to make the data smaller and easier to process while keeping the most important information. Pooling works by dividing the features map into small regions and then summarizing each region into the simple single number. The most common method is max pooling, which take the highest value in that small area. Another method is average pooling, which take the average of all value in the region. By doing this, pooling helps the CNN focus on strongest feature and reduce the amount of data of the network has to handle. Next, we understand the flattening and fully connected layers. After the convolutional and pooling layer, the CNN has many small features mapped, but these are still in the multidimensional forms. Flattening is the process of turning all uh, features maps into the single long list of numbers. Uh, so flattening papers the data for the fully connected layer, and the fully connected layer use these data to predict the output, like labeling the image as a cat, dog, or something. In next slide, we understand the CNN architecture. The architecture of convolutional neural network is a specific arrangement of layers designed to process and understand image. It usually starts the convolutional layer, which detect basic features like age and colors by applying filters over the image. After convolutional neural network, there are pooling layers that reduce the size of the data while keeping important information. This makes the network faster and less likely to overfit. This pattern of convolutional followed by the pooling can repeat several times, helping the network learn more complex features step by step, from simple edges to shape and then to objects. At the end of network, there are fully connected layers that are take the features extracted and use them to classify the image into different categories, such as identifying if the image is a cat or a dog. In next slide, we see the applications of CNN. Convolutional neural network are widely used because they are very good at understanding image and visual data. First one is the image recognition. CNN can identify objects in images like recognition, face, animals, or everyday items. Second is the face detection and verification. Third is the medical imaging, images, self-driving cars, video analysis, natural language processing. So thank you.